Okay, welcome everybody. In this video, I want to wrap up our discussion of positions, in particular, working with the position of bar plots in ggplot2. So we were working in this module pretty much exclusively with the Penguins data frame, and we were working with bar plots using really focusing on two categorical variables in the Penguins data frame, the species variable and the sex variable. Those two categorical variables each had three classes. There were three species in the Penguins data frame. There were three sexes in the data frame. We had male, female, and there was an NA sex because there were some observations where the penguin didn't have any sex encoded. And we talked about here is what looks like when we have a Dodge position for a bar plot. We can also set the position to fill, which creates a stacked relative frequency bar plot. And we can set the position, the default position, which is stack, which creates a stacked bar plot where we have counts on the vertical axis. So I want to think about a different data frame, which has categorical variables that have more categories. So in the ggplot2 package, there's a data frame called diamonds. And if you've read some materials out there on ggplot2, the diamonds data frame is like a classic data frame because it's got a lot of data in there that's really good at illustrating how to do exploratory data analysis and illustrating a lot of features of ggplot2. So we'll incorporate the diamonds data frame to illustrate some features of the position option for the bar geom. So here's the diamonds data frame. It's huge, right? It's got 53, almost 54,000 observations, 10 variables. We're going to focus on two categorical variables, cut and color. So these each have, so cut has 5 levels. So that's the cut of the diamond, and it's things like fair, good, ideal. And these are ordinal, since a good cut is better than a fair cut, and so on. So these are categories, and these categories have rankings in terms of this category is worse than that category is worse than that category. Color is also a categorical variable. There are 7 levels. They also have rankings. So the worst category, the worst color is D, the second worst color is E, and so on. So let's say I want to see whether there's some relation between color and cut of a diamond. So it stands to reason that if there are rankings of cut and color, that it might make sense that like the best color of diamond might line up with the best cut of diamond, and so on. So I'm going to create a bar plot to compare the color and cut of diamonds. So I'm going to input the diamonds data frame into my ggplot, and I'm going to create a global mapping for color and fill, color going to X, cut going to the fill. And my first plot is just going to be a bar plot with the default position of stack. There we go. So this is a stack bar plot. We've got counts on the vertical axis. I have 7 bars, one for each of the 7 colors. And then each of these bars has 5 colors stacked on top of it, one for each of the cuts. And here's what we get when we use the fill position. Now these are all kind of put on the same relative terms. So we're looking at relative frequencies. And here's the Dodge position. And you can kind of look at these plots and think about the relative merits or, what's pros and cons of each of these plots and how it helps present the data in meaningful or unmeaningful ways. And question 9 is saying, well, let's say we want to determine which color diamond has the highest proportion of good cut diamonds? Which plot is most effective at presenting the data so we can most readily answer that question? And what you want to be careful is that when you look at this first plot over here, that is, again, you want to be careful when you just compare absolute totals. So this color J, apparently that's the best color diamond. I'm guessing they're really expensive. There's not a lot of them in the sample. So this is really small. Compared to like G, we have a ton of those diamonds in our sample. So when I'm comparing counts, I would want to be really careful to say like the absolute size of this bar here in yellow is not larger than this bar in yellow over here. So J is not that likely to be ideal compared to I. We don't want to compare these in absolute terms just because this is a much smaller bar than this bar is over here. And so when we compare these on relative terms, this is much easier. This controls for the very different sample sizes that we have over here. So this is why I think using this position fill can be very helpful when we have samples that are very different sized. So now if I'm asking, okay, the question was, which color has the highest proportion of good cut diamonds? Good is the blue one. So if I'm looking at this plot, I'd want to say, okay, like which has the largest slice of blue? It would be misleading over here because I might just pick out G. And the only reason why G has the biggest slice of blue is just because G is the biggest bar overall. It might just have the biggest yellow slice, the biggest green slice, the biggest this other green, right? It just has the biggest of everything just because there's the most color G diamonds in our data frame. So if I look at this bar plot over here and I look at the relative frequencies, now I'm looking at these proportions relative to the number of diamonds that I have in each color. And so now if I want to say, well, which color is most likely to has the highest proportion of good cut, I'm looking at, well, which of these blue bars is the largest area in blue, and that is this area over here for F. So F actually has the largest area in blue. I think it's pretty close. I think F and J are probably pretty close to each other. It might be J. So we could compare these two areas, but I think F and J would be the two that have the largest areas in that are good. It might be J, but we can check this down below. Let me compute these tables. I'm just pulling this out of my solutions over here. So this is going to create a proportion table. This option 1 just means we're going to calculate these proportions relative to the totals in each row. So here's our good. And so here I can see out of this column of good, this is telling me that out of all of the J cut colored diamonds, 10% of them were good. And I think that is the largest percentage of those. So J would win. I think that's what I said. So that corresponds to this area in blue being the biggest. Whereas if I actually just looked at the counts, right? J does not have the biggest number of good cut diamonds. The largest number of good cut diamonds actually, I think, belongs to E, but that's just because we have a lot of E diamonds in our data frame and we don't have a lot of J colored diamonds in our data frame. But as a proportion, out of all of the J colored diamonds, it has the largest proportion of good cut diamonds. So just want to be really careful about how you use the position option and how you read these different data frames, and whether you're using counts or whether you're using relative frequencies to compare totals or proportions in different classes of different categories. Okay, so I will stop our discussion of positions and bar plots. We are almost done with this module. In the next video, we'll just talk about jittering real quickly, and then that will just about be a wrap for this module. Thanks, everybody.